Hello, I'm Eugene. I'm going to be presenting the last sprint problem, and this is the one about the stop sign and the yield sign, and sure enough, I got those two signs right there. And they even tell you how large the yield sign is relative to the stop sign. Like, you can get the yield sign connect two of these vertices, and then as well as the middle of that bottom one, to get the yield sign from the stop sign. And we want to find the ratio of the area of the yield sign to the area of the stop sign. Okay. First things first, I don't really know what the side length of this octagon is because this glorious 8-side figure, I forgot to measure it, but hold on. If we're only worrying about ratios, then we only have to worry about the starting side length. Most of the dimensions are going to be relative to one another, so we can just set the original side length of the octagon to be 1. Another observation I noticed at this octagon, if you extend some of those sides, this looks like it can be part of this 45, 45, 90 triangle. And if you do that for all that, then you get that the octagon fits inside the square. So I can do some more measurements. So the side length of the octagon is 1, and if you use your 45, 45, 90 thing, you get that the distance this one, the size of the 45, 45, 90 is going to be root 2 over 2, which means that the side length of the entire square is going to be 1 plus square root of 2. And now you get the area of the square, and then you subtract 4 of those isosceles right triangles. So you can do this setup, and then in order to continue on the math, you may need to do some expanding with squares and stuff, with foil and stuff. And once you unwrap the foil, you should end up getting 2 plus root 2 as your area. Now, as for the stop sign, yield sign, well, you can have this distance over there and this distance over there, so that could be the base and the height of the triangle. And fortunately, we already know some of the dimensions for the octagon, so we can proceed with the dimensions of the yield sign. So that length is going to be 1 plus root 2, and the height is going to be 1 plus root 2 over 2, because you're only adding one of those root 2 over 2 to the side length of 1 for the octagon. And then you can use your half base times height formula to get the area of 4 plus 3 times root 2 divided by 4. Okay, almost done. Now to get the ratio, we need to put the yield sign area and then divide that by the octagon area or so. Let's do that. So once we put that, we can get this set up. Oh, we're dividing by some radical thing. That's okay. Let's multiply by the reciprocal and get this instead. And unfortunately, none of the answer choices look like they're going to have radicals in the denominator. Oh wait, we can rationalize it by multiplying the numerator and the denominator by 1, or 2 minus 2 root 2 over 2 minus 2 root 2, which is basically the same thing as going to be multiplying 4 plus 3 root 2 over 4 times root 2 minus 1 over 2. And once you expand that out with some more FOIL and stuff, you'll end up getting 2 plus root 2 over 8 as your final answer.
Hi everybody, this is Tim. Hope you're enjoying our videos. If so, you know what to do: like, subscribe, turn on notifications, all that sort of thing. But what I'd really want to invite you to do is to send us an email at media@mathleague.org. Tell us which problems you'd like to see us cover next in our video series. Take care and see you in the next video.